a single source for things. You have a network at your disposal, which are all by the protocol reaching agreement with the data they store. So you could ask this person, what is the balance of person A? Same as that other node over there will say after a period of time, but the technical details will come to later. It's resilient because it's a distributed network, rather than say a centralized or decentralized network. It means if one of these nodes go out, you still have all the other nodes on the network, all the other nodes that are connected on the network, sharing the same data. So you can't attack, Amazon headquarters and take down all AWS servers, for example. Even if it's decentralized, they might have multiple servers around the world, but still a very targeted attack can take down some computers in the network. So here it's just very resilient, where the data is just always there and accessible. Similar to immutable and resilient is its censorship resistance, meaning if a government wants to come in and say this action never happened or certain things didn't happen, they can't, because they have to go to every computer on the network and try to hack every computer on the network and say that something didn't happen. Sorry, I just realized I'm pointing to one screen. Love you guys too, sorry. Don't want to leave anyone out. Finally, it's an interesting attribute of it. It's pseudonymous use. So some blockchains are actually anonymous, but most are pseudonymous, meaning you have an ID, like an account number, that you use to access it and do transactions, but it doesn't need to have any personally identifiable information associated with that. So that doesn't mean you can just run free and buy drugs on the black market. It means that if you're accessing this via a network, your IP address can be traced. So FBI can go in and find you. So although it's pseudonymous, that's the interesting part. Things are stored. All transactions are stored, but it's not necessarily associated with an individual unless someone really digs deep in. So what about the first applications of blockchain tech? Bitcoin. So what this blockchain technology does, as the previous speaker mentioned, it solves the double spend problem. It means once a transaction is written in history, it happened in that order. So let's say I'm wanting to pay 2 people. I'll send some, and I've only got one Bitcoin. So I send 1 Bitcoin to someone. I can't simultaneously send that 1 Bitcoin to someone else without a discrepancy being determined. So if in the ledger, as it's called, the data that's shared amongst the computers is a ledger, and if in that ledger one thing happened where I've sent money to someone else, my balance goes down, and then the next thing that I can do, I won't be able to send money again because I've already spent that 1 Bitcoin. So I can't go to one part of the network, spend 1 Bitcoin, then go to another part of the network and send another Bitcoin, because I've only got one. So it solves that double spend problem with the tech, but we can see a bit more of that in the tech detail, and if you have any questions, we can go into that. So this is the backstory. Every nice thing has its origin story, so Bitcoin begins. I needed a Batman logo here. So it started off the back of the 2008 financial crisis. Someone asked me to summarize Bitcoin, and I said, well, I could talk about it for an hour, 5 minutes. How long you got? She said 7 words. So I'm like, gosh, how do I summarize Bitcoin in 7 words? So I said, it's a response to the GFC. So that way, it sort of put it in context. Then she's like, okay, now tell me more, and then I could have time to expand. But it was just an interesting summary of it that sort of stuck with me when I first read that. It was a response to people seeing the government's bailing banks out, and they're like, hang on, surely we can do better. Why are we doing subprime mortgages? Why, all these things that they disgruntled with the banking system. So that's where Bitcoin begins. So with that sort of high-level overview aside, I'm going to dig a little bit into the tech, but I'll try to get these examples pretty clear. So person A and person B, Alice and Bob, they both have Bitcoin accounts, and Alice wishes to send money to Bob. So first, Bob has to share his his account address to Alice to say, hey, this is my account, please send something here. And then Alice signs a transaction with a private key to her account. So she'll have the account with an amount of Bitcoin in it, and only with her private key that only she possesses can she sign and say, send money from my account to Bob's account. That's written in a transaction signed with a private key and then put onto the network. That signed transaction is then propagated across the network, and then based on mining, which I'll touch upon later, it's added to one of the nodes gets to mine that transaction, added to the ledger in that order, then based on the algorithm that selects that particular node, it is added there. and then that update is propagated amongst the network. So that's sort of the blockchain protocol that allows that to occur. So signing of transactions, and then a random node validating that transaction, and then it being distributed along the network. So again, the whole network will be reach consensus on the data, on the order of operations in their ledgers. So now a little bit techie again, just to where blockchain comes along, the name came from. So the ledger is actually a collection of blocks, and within each block is an ordered list of transactions. So here we have a block that has transaction 41, 42, 43, 44. That's just the order that node happens to have assembled it in. And with each block is also a hash. So this hash is, actually now, raise hands if you're familiar with what hashing is. So we've got actually a fair bit familiar with hashing. So what it does in summary is gets any amount of data and does some computation to bring it down to a fixed length. So it becomes like a unique, not quite signature, but a unique representation of that data. So you could get the complete works of Shakespeare, create a hash that's 250 bits long. You could get a spacebar character, and that'll also be 256 bits long. If you, instead of space, you have space, space, it's a completely different hash. Like it's the same length, but it's completely different, and practically it looks random. You can't quite guess, what a hash will be based on the data you've got. You just have to sort of pump it through the hashing function, and then you'll end up with the hash of the data you have. That's important because the blocks are chained together by the next block referring to the previous block's hash. So that way you know which order the blocks came in. So that first block has transactions 37 to 40, and then it calculates its hash. The next block that gets mined, again, at random on the network, one of them says, yep, these are the next transactions to go in the ledger. Here is the order of these transactions. That contains the hash of the previous block, and that's how it's chained together. Then at the end, it calculates its hash with all of that data, and then the next block again will have to do that, and it'll run its hash function and create its hash for its block, and so on. So that's sort of I guess it's pretty technical detail, but it's roughly what happens. Now there's this extra bit of data I skipped until now regarding, so that's also in each block, and it's called the nonce. What that does is allow, to work out this randomness, like how do we pick at random which node sort of adds the transaction? Because if you're always getting one network always adding the transactions, they can have some power. They can sort of reorder transactions. They have some power in doing that, so it has to be random. So how does that happen? We have this little number called the nonce, and based on that nonce, you're changing the data. So like I said with hashing, if you change a little bit of that data, you completely generate a different hash. So that's what this is relying on. You change the nonce by 1, 2, 3, you just keep incrementing that nonce, you're going to get completely random looking hashes. And I think it's meant to be roughly uniformly distributed across the space of 256 bits. But yeah, if you are sitting there, like you're one computer on the network, you're saying, okay, I've got these transactions, but I have a challenge now to be included in the network and for the network protocol to accept this block as the next block. I need the hash to exist with, say, the challenge is 4 preceding zeros. So then everyone on the network is sitting there, okay, the challenge is 4 zeros. They're going to sit there changing that nonce one by one, or if they've got lots of computers, they'll be all maybe spreading themselves across the space of the nonce and saying, okay, I'm going to hash all the nonces from 0 to 10. I'm going to hash from 11 to 20, and so on. So this nonce is being changed, and then the hash is being computed to get a different hash of the block, until finally one of the computers will fall upon a hash that is preceded with 4 zeros. They then declare that to the network, and that is the next block that gets included. So, yep.
Which part has the address of the previous block?
Yep. So so the nonce is just an extra bit of data inside the block,
yeah.
And this is a hash representation of the block. And then the previous hash is at the beginning of the block. Inside of the transactions that contain account addresses. So does that answer the question?
Are account addresses the address to your previous block? Or
Okay.
how is the link made? Is that a pointer?
Right. Yep. So the account addresses are actually only included inside the transactions. So within each transaction row, like we saw here, each of those transactions will have a from address and a to address to say, spend Bitcoin from this one and add it to the next one. And that's inside a transaction. So those account numbers are only inside there. Block hashes are a different thing. There's block number and a block hash. I'm not actually showing the block number here, so it would be like 3, 4, 5 is the block number. But the block hash is kind of like the unique identifier of that block as well. Like that will be unique for that block. And yeah, so this effectively, the previous block hash, sorry, I keep doing that. The previous block hash effectively acts as a, do I have a laser? Yes. So yeah, the previous block hash affects as the pointer to the previous block. So blocks can point to each other based on the hash. The account addresses are only within transactions. Yeah. So that's the nonce. So this is what comes to mining. So everyone's heard about mining, how it's energy. Oh, sorry, we had another question.
Yeah, just with the see, we know that the node that calculates the correct nonce is throughout the block to the blockchain. How does the majority voting system come into play in terms of who mines the block?
The majority vote. Yep. So that's probably going to come into the next
okay,
one.
no problem.
Awesome. Yeah. So here's where mining comes in. So because you're just having to do this hashing function with a lot of computational effort, it just takes energy. So those who have computers in countries with cheap energy, those who don't have to spend extra on cooling, who actually are in colder places. Some Bitcoin mining rigs have gone out to, I don't know where, sub-zero climates and then set up their server farms there such that they could just sit there, churn this random nonce until they get something that gives them the hash, the transaction hash that they need to be accepted. Now the reason why people are spending money on that is because it's rewarding. Those that have blocks added to the network get a financial reward. I'm not sure of the amount of Bitcoin for Bitcoin, but Ethereum is also the same thing. It's another currency, but it's also rewarding blocks in the currency that they're mining. So this incentivizes people to spend money on servers to put onto the network. So rather than, say, paying a hosting company to spin up a number of computers, each node is actually incentivized to participate in the blockchain network that it's supporting. So in this case, we're talking Bitcoin. So the smaller your amount of servers are, or if you're just doing a home computer, your odds are quite low of being the first to get that block. You might get lucky, but stats are sort of against you there. And you get bigger server farms that are sitting on your study floor. It's heats up the room a lot. So a lot of stories of early day Bitcoin Americans in the dormitories they didn't need heating in the winter because these things were churning away. And then you've got fully professional server farms who just optimize it to the nth degree, right down to the silicon level, but I won't go into that, to get very effective hashing power. So they're churning so many hashes out, and they're the ones who are more likely to get chosen to do the block. And that has its shortcomings, which I'll touch on. The alternative to staking energy to get the block is to stake the amount of the currency of the block, so say Bitcoin. So a small computer can stake a couple of Bitcoin and said, I'm going to put this amount forward, and this gives me effectively more odds of getting picked. So rather than everybody, say, guessing for a lucky number competition until they get a computation that gives them the number they want, this is more like a raffle. The more you stake, the more chance you have of getting picked. So once, I'm saying nonce, but I don't think it's quite nonce, but instead the network would just pick a random nonce and then it said, okay, who had that nonce? And then the more tickets you bought, the more likely you are to have fallen upon that. So if everyone's done a raffle, that's sort of how that works. Yep, so that's more energy efficient and faster. So rather than computers sitting there mining away, spending energy to add transactions to a ledger, we just have something that says, okay, how much is everyone putting up front for this? Okay, at that point, pick one. The person who gets it adds the transaction. So this is all quite intricate and, again, going the motivations back to the GFC, and there was a lot of motivation too. There's a lot of smart people like Satoshi Nakamoto getting behind this and writing this draft paper and getting it out there, then a whole lot of people getting on board. What's the first significant use case of this? Give a little hint. Someone know? What was the first use?
Is it buying a pizza or something?
Oh, actually, yeah, that was actually it. What was the first sort of marketplace, maybe, I'll say? Silk Road. Boom. So, yeah, with this beautiful technology, you've got all these smart people making it, saying, hey, we're going to free the world and make everything a better place. Drugs. And I think weapons and I don't know what else. But some really bad things hit there around 2011. But that was quickly shut down in 2013 by the FBI. And I think Phil mentioned that it was just last year that Ross something or other, I can't remember his name. What was his name?
Ulbricht.
Ulbricht, yeah. Yeah, it was just jail and whatnot. So he's been
2 life sentences.
Oh, 2 life sentences, yeah. So he was finally given 2 life sentences for his participation in this. So yeah, just to read the quote there, Silk Road has emerged as the most sophisticated and extensive criminal marketplace on the internet today. So, and that was then. But so since 2013, the Silk Road hasn't been there. I'm sure there's been maybe other things, but that's a long time ago. Like Bitcoin was such a low value then. I wish I'd invested then. We've had some people, a colleague was telling me about it. He's saying, oh, there's this Bitcoin thing, I'm going to do Bitcoin ATMs. And I'm like, well, what is this digital money? It sounds crazy. And I was in tech, so it's silly me not listening. So yeah, other currencies, touch upon that, yeah. So the thing about the blockchain protocol is that it's open. So it was published as a white paper, or maybe it was called a yellow paper, I'm not sure. But it was published as a theoretical paper, and then people were implementing it as open source software. So other people could say, I'm going to copy this code and I'm going to rename it and tweak a bit of the parameters and run something else. So one of the first examples after Bitcoin, I think, was Litecoin. They got the Bitcoin code, made Litecoin, which was meant to run faster and do less things, but just faster. The other ones that came out was a whole bunch more now. So there's a lot out there. This was taken recently from Wikipedia, thanks to Mikhail. And another one that existed was, it was called Darkcoin, and obviously that sounds quite ominous, but it was meant to be a purely anonymous cryptocurrency, and it still exists today, but it's got a much nicer name as Dash. Sounds great. But yeah, there's so many other cryptocurrencies out there. Can anyone tell me what that one is? Dogecoin. Much wow. So coins that are just spawning, like there's just so many of them, so many little ones. I'm not sure if it's censored, but it's called, yeah, shitcoins. But yeah, so there's a whole lot of other that takes up a lot of this market. So people are just spinning up their own blockchains. Miners are incentivized to get on board because they have potential rewards of that currency. And so yeah, all these other networks flourish, and it's about convincing people that you are going to be good, you're going to get a whole lot of people on board. And Doge is a great rallying point. Everyone just got on board in that group. There's a God coin as well. But the blockchain, yeah, different blockchain technologies can do more than just a simple subtraction and addition between balances. That's effectively what a transaction is. It's checking, is there enough money in the first account? If so, subtract and then add to the other account. That's a bit of computation, but it's very little. Right? We can do more. We can actually do more complex things. So rather than just signing a transaction like we saw, so rather than just signing the transaction and sending that to the network, and yeah, signing the code and sending it on, instead, let's sign some code interaction. So this little back code. So you're saying, okay, here's a smart contract. I want to interact with it. I want to do some more complex computation. So that's what they say I'm interacting with. They sign that and put it onto the network. In the same way that one of the nodes processes a transaction to do the balance subtraction and balance addition, it says, okay, I'm going to mine my block the same way, but I'm actually going to execute more complex code than just plus and minus and plus. So you get smart contract, I mean, an example, but you have code. So this is what the Ethereum virtual machine does. So this is not Bitcoin, this is Ethereum. I think Bitcoin has some scripting capability, but Ethereum has full-on what's called a Turing complete machine, where you can do yeah, full-on source code. Any questions so far? So some of the smart contract standards that exist are ERC 20 tokens, so they're the most common ones. They're like another currency because people are doing ICOs, initial coin offerings, not only of the blockchain coins, but also of tokens that exist on top of the Ethereum network. So it's a bit of inception, like it's a currency within a currency, if you will. So a token exists on top of Ethereum that people can transact in their tokens in the same, by sending ether to a smart contract. You can be given an allocation of tokens. You can send tokens to someone else based on the smart contract interaction. So it's just another layer above a blockchain. So rather than having to spin up your own blockchain to issue a currency, you can spin up a token. And then, yeah, and that's sort of a currency within your network. So if you're offering a product or something, and you say, my product relies on having these tokens and spending these tokens, that's what the ERC21 is about. ERC721 is a non-fungible asset token. So this is meant to get into law talk now maybe. But yeah, this is around ownership of a specific thing inside that smart contract. So according to that smart contract, you can purchase a unique thing. The first unique thing, the first significant ERC721 token that took off, actually, who knows that? Who knows the most? Phil? CryptoKitties. So again, this beautiful technology can do so many wonderful things, maybe title deeds, maybe digital asset ownership, art ownership, well, it can do so many things. Wait, CryptoKitties. But yeah, so, well, I guess it is. Yeah, digital asset that you own. Oh yeah, it's a virtual cat. So yeah, so basically this company made some digital images of kitties, and you are owning the unique number that represents that kitty. That's it. So that unique number, people are paying hundreds of, maybe thousands? Was it? I don't know. Oh, there we go. $130,000 for the most expensive 250-bit number. I mean, CryptoKit. So that's the thing. Under the hood, it is just a number, but their website represents it in a way that shows people you own this cat. Boom. So moving towards applications, it can do more than just buy and sell kitties. You can have more intricate logic inside there. So if we take, for example, yeah, so if we look at some other possible applications around escrow, where you can send money to a smart contract and saying, I'm beginning an escrow contract with this other address, and if there's a digital trigger to say that the goods have been transferred, or some technology you give, it can then release the funds to the seller. So that logic can be codified. Provenance, I think, touched upon the example there around provenance. The hardware example there, so the other half of me is sort of IoT, and I like looking at hardware interactions in that. So the examples I've heard for provenance are around fishing industry, so to transport fish from farm to shop, I guess, requires that they're transferred at a certain temperature for the whole way. So yeah, if someone's transporting the goods and the temperature drops below a certain temperature, they can actually be liable to pay more because of that. Don't leave it. Insurance, so you can do group insurance, so you don't need a centralized company to do that. Maybe everyone puts their money in, and once a valid thing occurs, the money or part of that money gets sent out. The difficulties will always be around where the blockchain contract hits the real world, but I think that's what lawyers don't have to do all the time, right? They have to go from what is written in the contract to how it actually applies, what is interpreted, which is an interesting part. I am going to touch upon both, for example, some people in that as well. So yeah, so I think we can wrap it up.
James, just to push your time to limited, but can I just flag the whole escrow issue? And we think we have some lawyers here as well. We'd love to cover the escrow issue in terms of who's actually owning that money, whose responsibility is to own those funds. Because you know the typical escrow account, as I understand, is like a trust fund, whereas this is not really a trust fund. You in fact don't have that money and well, you have it under control via the contract, you don't actually have that money under your control.
Yeah.
So it raises some really interesting legal questions, which I'd love someone to
okay, so maybe we'll save later. So we'll save questions at the end regarding escrow and then the legal implications of that. But yeah, we'll flesh out some examples after that. So what was I going to say? Yeah, so in I guess like the previous speakers talked of saying about restructuring legal documents to be in a way that the computers can understand better or can be leveraged by computers and machine learning and so on. I've sort of seen smart contracts and the way I look at code. First you look at it in pseudocode, you think of it in logic. Okay, so you look at it in logic and say if this then that kind of logic. And even if a parsing of source code is considered like grammatical, like it's sort of you've got very strict grammar. Now, I presume legal contracts are the same. Like I've heard of a few cases, like one last year and one maybe 2 years ago regarding Oxford comma and how people can lose millions based on a misplaced comma or a non-existing comma where there should be one. And that's very interesting because if that contract was drawn not in a long paragraph with commas appropriately placed and drawn instead as a flow diagram, that would be much clearer. And that's from a flow diagram, you can write code. So I think there's a nice stepping stone from from what is English grammar to maybe a flow diagram if possible. So if lawyers want to code in contracts and pictures, I'd be very happy. And then after that, we could just code smart contracts from those pictures, and it would be one-to-one mapping of the logic. So I think that's actually it. So what can you use it for? Thank you.
What we're going to do now is I'll just forget that. I'll hand you this and we can question and answer. We'll get the
Yeah. Oh, do you want to pass that?
Yes, you can speak into your.
Oh, and then pass it around. Yep. Thank you. Okay. Questions? Yep. I'm just going to pass the mic. So we'll prep the mic before you ask.
Thank you very much.
Oh, sorry. That's fine. I'll come back.
I was going to jump in the corner.
That's okay, I'm good, thank you. I've got one of the fundamental questions about blockchain, how that's going on the US scale. Do you have any comments on that in regard to the blockchain?
Yeah, so we saw proof of work there, and that being quite energy consuming and time consuming. But then there's proof of stake, which is coming. So that's of the Ethereum network, proof of stake will be coming soon. But outside of those technologies that require a major blockchain change, there are other technologies. There's called side chains, or things that occur off the blockchain. So let's say there's a specific interaction, a specific use case. You could do that off chain, have that interaction then verified and report it back on chain. So that way you're only using the blockchain and its slowness for the important interactions that you'd like to write.
James, whether this is maybe the session discussed, maybe possibly one of the later sessions, the whole escrow aspect of the blockchain and of contracts, and let me illustrate what I'm saying by giving an example. For example, if you're about to buy a house, your lawyer might hold some funds in escrow and a trust fund, or the estate agent might hold those funds, but it's physically in their possession and they're responsible for those funds. In the case of putting a smart contract up, where those funds are in fact locked in, and it will be effectively the same outcome where they are transferred across the sale of the house. Are there any legal obligations? Now, specifically asking from the perspective of ASIC, because it impacts the way you then interface with ASIC.
Yeah, so I'm probably not the best to answer legal questions or give legal information that you identify. But my thoughts there are that it would be like the smart contracts, I think, would become the binding agreement where you agree to the flow that it will sit in this contract. And you both sign and say, yes, that contract will hold it under these terms. Maybe there's a time release clause as well as a release based on condition being met, such as the transfer of ownership. So we've already had an example of domain names has been handled well. So already even low value ones are currently working, but I think the high value ones are probably quickly as well. Some questions over here as well, sorry.
No, it's just shaking head. I think there's something
Okay.
to say to that.
You would?
Question.
Yeah.
Just on that, you mentioned from ASIC and see all the changes coming through. And how the judge time takes to say that the is more or less coming through. There are a lot of issues with them. One of the big ones is ensuring that practically take the state power to substantially use the blockchain. You're also assuming that say the blockchain is great, maybe mathematically perfectly if you have a blockchain-based system, still have an increase a lot of times. You replicate the blockchain, so you're looking at the individual or the individual person who holds money and so on, that's where the money is across. However, in reality, you have a factor that's shared in the end, which if you have that self-practical, just so long as you know the factor in the whole part, which is often the thing that doesn't be allowed for. So what we do, I think, is that we will take time.
And that's the thing I always look at. Like I get this the luxury of looking at the simple IoT connection to the physical world and how hard that can be. So let's take the fishing container, like transport of fish from a thing like if you have one sensor and you're trusting the accuracy of that sensor, okay, we can have it regularly calibrated and have a maintenance schedule of that sensor. But what if that sensor breaks on the time it's transferred? Okay, well you need maybe redundant sensors, and how many of those do you need around? Like getting in touch with the physical world just from a machine point of view is messy enough, but you know, it's a tractable problem. But coming down to people, it always has to come to, as you say, touch points. It has to come out to real people in the end, and that's where it's going to be as it was before. Although I love the tech behind blockchain and what it can bring, I definitely don't think it's going to replace you know, people from their jobs. It will make certain jobs easier. It will make things maybe more visible and a bit more machine-like. Like certain logic can be just encapsulated in a smart contract, and just everyone will know that's how it will play out. But still, in the end, no. And still in the end, then it will be the other people's interpretation of whether this logic flag was true or false. It is a real world. Some other questions?
I think we actually need to wrap it up.
Sorry, okay. Thanks everyone.
So everyone put your hands together.
James also
Yes, sorry about that.